Hey guys, so I'm going to do one more example of practice with finding a molecular total and net ionic equation. I do have another video on it that may be a little more detailed, but I did want to do one more example because I find students typically tend to struggle with these because they can be a little tricky. So if you're struggling with these, don't be too discouraged, it's normal. So in this one, I'm given these two reactants, and they have already told me that they're aqueous. If they didn't tell me that they were aqueous, then I would have to determine that for myself and look them up and make sure that they were aqueous. And by aqueous, that means that they are going to dissolve in water, and most likely do that in the reaction. And so that will matter when we write out our total equation, because we have to write it out as if they dissociated. And so if they're aqueous, they're going to dissociate. So the first thing we need to do is find what our products are. And the way we do that, or the way I do that, is called the inner-outer method. And so I color code to help. So by inner, I mean the two, sorry, my computer keeps going off. So by inner, I mean the two inner parts of the equation. So if you'll look here, nitrate is on the inside near the plus side, and so is hydrogen. So I'm going to combine those two together. And then, trying to color code, my outer would be this element with that compound right there. Okay, so I'm going to combine those together. So what's that going to give me? Well, do my arrow to the right for yields. And when I combine, so I'm combining, and if it helps, just write it out. I'm combining NO3 2 with H2. So how is that going to work? Let's see. We're going to do, well, if you look at it, there's two nitrates and there's two hydrogen. So I could just rewrite it like this. So I put a 2 out front, which means I have two hydrogen, two nitrates, so they come together. Now I put hydrogen first on purpose because we always want to put the metal and then the non-metal. We always want the metal first. How do we know if it's the metal or non-metal? All we have to do is look at our periodic table. If it's on the left side, it's going to be a metal. If it's on the right, it's a non-metal. Okay, and we know hydrogen's on the left, so clears that up. Okay, so that one's took care of, so we can add it up here. So 2HNO3. Now, if you look that up, it is going to be aqueous. Okay, so now I've got to combine CD with SO4. So there's only one CD and one SO4, so pretty simple. I just smush them together. It's probably not a scientific term, smush, but anyways, CdSO4. And if you look that one up, you will find that it's going to be a solid. And hint, hint, there's always in these problems going to be one compound that is a solid. So you should have at least one solid regardless. So just note that. Okay. So now the next thing we would need to do is balance our equation. In this case, I know that it's already balanced, so I'm not going to waste my time to do it. If you're not sure how to balance an equation, I do have a video on that, so if you want to go watch it, on my other video of ionic and total net ionic equations, I show how to balance the equation as well, if you want some practice with that. Okay. But I know it's balanced, so I can move on. But I do have to balance it. That's not optional. So the next thing I'm going to do is I'm going to look at all my aqueous compounds. So aqueous, aqueous, aqueous. And I know that all of those aqueous compounds are going to dissociate. And by dissociate, I mean they're going to break apart into their constituent elements. So let's break them apart. And when they break apart, we're going to need to write the charges on them. So CD is going to have a 2+ charge, and I can tell that because I know that 2 down here is going to make it go up there for the charge. And then I'm going to have nitrate, which always has a 1- charge. Okay. Now hydrogen, so this has a understood 1 here, so hydrogen is going to be a 1 plus charge. And so let's see, this one's going to be, so I see this 2 down here, that's going to let me know this is going to have a 2, it's going to have a 2 minus charge. SO4 2 minus. Sulfate. Okay. Alright, alright, now, so we got those breaking up. Now let's look at our product. So we got to break this one up, and we have to account for this 2 because that means there's 2 hydrogen and 2 nitrate. So we'll have 2H plus 2 nitrate, and we can't break up our solid. So whichever one is the solid that's not aqueous or dissolvable in water, we cannot break it up. We will still write it for our total equation because it's included. However, we cannot break it up into its ions. Okay, so this that we just wrote will be called our total ionic equation, or a total equation, whichever helps you remember. The key word there is total because it includes everything. Everything's included. We have not left anything out. Alright, now we need to find our net ionic. And by net, it means what is actually participating. So we need to figure out what our spectator ions are because they're not participating. They're there in the total, but they're not participating in the reaction. So we're not so worried about those. So how can you identify the spectator ions? Well, if you see it on the reactant side and you see it on the product side, then you know it's a spectator ion. So if I look, I see nitrate here and nitrate here. So I can cancel those out. And I see hydrogen on this side and hydrogen on this side. So I can cancel those out. Alright, so now I write what's left. I have CD, and you still keep the charges, combined with sulfate, yields my solid. Alright, and that will be my net ionic equation. And to make sure it's right, you should be able to combine these 2 elements to get this compound, which I can. And also your product of this compound should be a solid. Alright guys, let me know if I can help you in any way. Thank you.